Hi, this is Stan Lyle with MasterMath. During the lesson, you're going to come to some You Try It slides where you're asked to do problems that relate to the lesson. Hit your pause button, try the problem, and then hit the forward key to move on to the answer. I hope you have a really good time today. In this lesson, we're going to work on factoring some more. We're going to factor equations like this. Well, not exactly like this. This is a generic example of a polynomial. Or a trinomial. It's also a quadratic. And we're going to work on factoring it. Now, in the previous lesson, we factored quadratics where the a was equal to 1. In other words, it was x squared plus bx plus c. Well, what if a doesn't equal 1? Well, we're going to work on factoring when that's the case. And we're also going to figure out why we need to factor. Well, I'll tell you why. We're going to factor in order to get solutions to problems. And we'll get those solutions by figuring out what the zeros are or what the roots are. Let's look at an example. Let's say I had a rectangle and I knew that the area was 100 square inches. And I knew that one dimension of the rectangle was x inches and the other dimension was x minus 15 inches. Well, I'm a smart cookie and I know that that area equaled the length times the width. So the length, x, times the width, x minus 15, has to equal 100. And then if that's the case, I can carry out this expression and make it read x squared minus 15x equals 100. Well, I can manipulate that equation even further. I can make it read x squared minus 15x minus 100 equals 0. And now I've got a quadratic. Now I've got a trinomial. X squared minus 15x minus 100. And I can factor that. I can factor that to x minus 20 times x plus 5 equals 0. Now, if x minus 20 times x plus 5 equals 0, then I know that either x minus 20 equals 0 or x plus 5 equals 0, or both x minus 20 and x plus 5 equals 0. Well, if x minus 20 equals 0, then x equals 20. X, this dimension, could be 20 inches. If x plus 5 equals 0, then x equals minus 5. And this dimension would be minus 5 inches. Well, in the real world, it probably can't be minus 5 inches. It's probably got to be 20 inches. So we can say that this dimension, x, is 20 inches. Let's test it. X times x minus 15 should equal 100. Well, we'll substitute 20 for x, and we'll get 20 times 20 minus 15 equals 100. That's 20 times 5 equals 100. And it does. And if we were to graph that quadratic, x squared minus 15x minus 100, it would look just like that. Now here's the interesting thing. That yellow curve that represents x squared minus 15x minus 100 crosses the x-axis at minus 5, 0 and at 20, 0. And those are our solutions, 20 and minus 5. Now, we call those two solutions the zeros or the roots of the polynomial x squared minus 15x minus 100. Now you try this one. Hit the pause button, do the problem, and then hit the forward key to move on to the answer. find the roots. Well, that just means to factor this and solve it that way. So let's factor x squared minus 4x plus 4. The a coefficient is 1, so there's really no factoring to do for the x squared. But we can factor the positive 4. And it's a positive 4. So my factors are either going to be a positive number and a positive number, or a negative number and a negative number. If I had a positive and a negative, then my c coefficient would be negative. But it's positive. And I can think of a couple of different options. It could be positive 2 times positive 2, or negative 2 times negative 2. It could also be positive 4 times positive 1, or negative 4 times negative 1. Well, I've got a couple of different options at work. How am I going to get rid of some of these and come up with the real answer? Well, we'll do that by looking at the b coefficient. And it's negative 4. Now we're going to add the two factors together, and they have to equal negative 4. 2 plus 2 doesn't equal negative 4. 4 plus 1 doesn't equal negative 4. Negative 4 plus negative 1 doesn't equal negative 4. But minus 2 plus minus 2 equals negative 4. So my roots are x minus 2 times x minus 2. And x minus 2 has to equal 0, and x equals 2. So my solution is 2. Now if I were to graph this solution, it would look just like this. And you'll notice that there's only one solution, and the curve only hits the x-axis in one spot at 2, 0. If there's only one solution, then the curve will only hit the x-axis once. And we've been doing a lot of factoring recently, but up till now, all our factoring has been where the a term was equal to positive 1. But the a term doesn't have to equal positive 1. For instance, it could equal 2, as in 2x squared minus 7x plus 3. And we can factor this, but it's going to be a little bit harder. Now I'm going to show you two different methods of factoring this. The first one's a little bit more of a shortcut, and you can use this on easier factoring jobs. And the other method is to create a full-fledged spreadsheet or matrix to consider every single possibility. And you do that on harder jobs. So let's try the simpler job this time. We won't create a matrix. We'll just first say, how will I factor that 2, the a coefficient? And I'll factor that as 2 times 1. Now I got to factor my c coefficient, the positive 3. But in order to figure out what the possibilities are, I'm going to consider the b coefficient, which is minus 7. Now since I'm going to be adding my two factors together, I have to get a result that's a negative number because my b is a minus 7. I could factor the 3 into a 1 times a 3, but if I add a 1 and a 3, I get a positive number, not a negative number like my b term. So it can't be 1 times 3. My factors have to be negative numbers. And I can really only factor 3 and get negative numbers. I can only do that one way. Negative 1 times negative 3. Okay, so I know the factors of my a term. It's 2 and 1. So I can start creating my factoring by putting 2x, leaving a blank, and then multiplying that by the expression x, and then leaving a blank. And I'll put my c factors in those holes. But I got to figure out which c factor goes in which hole. One possibility is that I put the minus 3 with the 2x and the minus 1 with the x. But there's another possibility. I could put the minus 1 with the 2x and the minus 3 with the x. Now remember, we're trying to get the b term, in this case minus 7. And we're going to get that with the two middle letters of FOIL. The O and the I are going to be added together. We're going to multiply the outside terms and add it to the inside terms. Well, let's do this first expression first. 2x minus 3 times x minus 1. And we're trying to get that middle term, so we'll get the two, multiply the two outside terms and add it to the multiple of the two inside terms. So I've got 2x times minus 1, and that equals minus 2x. And I'm going to add to that the two inside terms, minus 3 times x, or minus 3x. And if I add minus 3x to minus 2x, I get minus 5x. Now let's try the second one, 2x minus 1 times x minus 3. In this case, I get minus 6x plus minus 1x, and that equals minus 7x. Minus 7x. That's my middle term. That's my b, minus 7. So this has to be my answer, 2x minus 1 times x minus 3. Try this one. Hit the pause button, try the problem, and when you get finished, hit the forward key to move on to my solution. All right, let's factor this quadratic. First we'll factor that 3. Yeah, it's pretty simple. 3 times 1. Now we need to factor the positive 10, and that's a little more complicated. But the first thing we're going to do is look at the sign of the b term. It's negative 17. So I know that the factors of my c term have to both be negative numbers. Now it could be minus 1 times minus 10, or it could be minus 10 times minus 1, or it could be minus 5 times minus 2, or minus 2 times minus 5. Now let's try all these combinations and see what we get for the b term. If we combine the 3 times 1 and the minus 1 times minus 10, we end up with 3 times minus 1 plus 1 times minus 10, which equals minus 13. Remember, we're using the O and the I in FOIL and adding them together. Well, negative 13 is not my b term. My b term is negative 17, so it's not that one. How about the second one? 3 times negative 10 plus 1 times negative 1. Well, that equals negative 31, and my b term is negative 17, so it's not that one. How about the third one, minus 5 and minus 2? 3 times minus 5 plus 1 times minus 2 equals minus 17. Minus 17, oh my gosh, that's my b term. Minus 17 is my b term. So I don't have to go any further. I don't have to check that last one. I know that it's minus 5 times minus 2. Now I just got to put it together with the 3 and the 1. And you'll remember I'm multiplying the 3 times the minus 5. So the 3 and the minus 5 have to be in separate factors. They can't be in the same factor. My 3 has to be in a separate factor from my minus 5 because I want to multiply them together. So my factors are 3c minus 2 times c minus 5. There's another more systematic and thorough way to factor an equation, and that's by creating a matrix and listing all the possibilities. So let's factor 3x squared plus 14x minus 5 using a matrix. And you can see I've got one column for factors of 3, and that's my a term. I got another column for factors of minus 5. That's my c term. And then I get another column for possible factorization, and then a last column for a summary of what the middle term is, the b term. Okay, well, Factors of 3. What are my possible factors of 3? Well, it's positive 3, so it's 3 and 1, 3 and 1, 3 and 1, 3 and 1. And I'm listing 3 and 1 4 times just because I know that I'm going to have 4 different possibilities for the factors of my minus 5. And what are the factors for my minus 5? Well, it's minus 5. So I know that my two factors have to be a positive number and a negative number, because I'm going to multiply them together, and only a positive times a negative results in a negative product. So one possibility is 1 and minus 5. But it's also true that it could be minus 1 and positive 5. Now I need to reverse the 1s and the 5s so I get every possibility. So I'm also going to list in my matrix 5 and minus 1. And I'm also going to list minus 5 and positive 1. Now let's work out the possible factorization. The 3 and 1 combined with the 1 and minus 5 is 3x plus 1 times x minus 5. The 3 and 1 and minus 1, 5 would be 3x minus 1 times x plus 5. The 3 and 1 and minus 5 is 3x plus 5 times x minus 1. And the last one is 3x minus 5 times x plus 1. Now I'm going to calculate the middle term. And you remember, that, again, that's the O and the I in FOIL added together. It's the two outside terms, the product of the two outside terms added to the product of the two inside terms. So in the first case, it's minus 15x plus x, and that equals minus 14x. Well, we're trying to get to positive 14x, so that's not it. And the second possibility resulted in 15x minus x, or 14x. Well, that's what we're shooting for, 14x. So we know what our answer is. We don't have to do these last two because there's only going to be one answer. And that answer is 3x minus 1 times x plus 5. You try this one. Hit your pause button, try the problem, and then hit your forward key. Factor 4x squared plus 9x minus 9. Well, that's a complicated factoring job, so I can't do this in my head. I can't do this the simple way. I need to create a great big matrix to solve this, so that's what I'm going to do. And I'm not going to go through every step with you right now, but I'll go through it in general. First, we need to factor that 4, and that could be 4 and 1, or it could be 2 and 2. Now we need to factor the minus 9. It's minus 9, so it's going to be a positive factor times a negative factor. And it could be 3 and minus 3, or minus 3 and positive 3, or it could be 9 and minus 1, or minus 9 and 1. And then I have to repeat those possibilities for the second factor of the A term, 2 times 2. So I've got 8 possibilities. And when I create those factors and then multiply out to get the middle term, I can see very quickly that my second possibility is the only one that gives me a positive 9x. And remember, once you come up with the right answer, you don't have to try all the other combinations. You can stop right there because you've got the solution. It's 4x minus 3 times x plus 3. All right, factor minus 2z squared plus what? Minus 2. Oh no, that looks so complicated. Oh, I'll never be able to do that. I hope that there's some simple way to make my life easy so I don't have to worry about that negative number in the front of this quadratic. You say there is a way? Oh, I see. All I'd have to do is factor out a negative 1. I could change that expression to minus 1 times 2z squared minus 5z minus 3. Now remember, because I'm factoring a minus 1 out from the entire expression, all my signs are going to change, not just the first sign. It's going to be 2z squared minus 5z minus 3. Well, now all I got to do is factor that term, that quadratic, 2z squared minus 5z minus 3. And we'll use a matrix to do that. My a term factors to 2 times 1. My minus 3 has to be a negative number times a positive number. So it could be 3 times minus 1, or it could be minus 3 times 1. Or, to get all the possible combinations, I got to reverse those first two combinations and also include 1 times minus 3 and minus 3 times 3. Now I create the possible factors and add them together, multiply and add them together to try to reach that middle term, minus 5z. And I can see that my third possibility results in a b term of minus 5. So my factors are 2x plus 1 times x minus 3. But I've got a minus 1 in front of that because all I did was factor the last part of this and I didn't touch this minus 1. So I got to bring this minus 1 down, and I could simplify that to just minus 2x plus 1 times x minus 3. Okay, here's one for you to try. Hit your pause button, do the problem, and then hit your forward key to move on to the solution. Well, to factor this expression, the first thing I want to do is get rid of all those negative signs. So I'm going to factor out a negative 1 and rewrite this as negative the expression 2c squared plus 5c plus 3. Now I'll factor that quadratic. The 2 factors to 2 and 1, and the positive 3 could be 3 and 1, in which case the factors would be 2c plus 3 times c plus 1. Or it could be 1 and 3, in which case the factors would be 2c plus 1 times c plus 3. Or it could be minus 3 and minus 1. Minus 3 times minus 1 equals positive 3, in which case the factors would be 2c minus 3 times c minus 1. But wait, could it be 2c minus 3 times c minus 1? My b term is positive 5, and I'm going to be adding my outside product plus my inside product. Well, my outside product would be a negative number, and to that I'm going to add another negative number. So my result's going to be a negative number, not a positive number. So minus 3 and minus 1, or minus 1 and minus 3, could not be factors of this quadratic. So we don't have to consider them. But we do have to consider the first two. My outside product plus my inside product of 2c plus 3 times c plus 1 results in a middle term of 5c. And that's the answer that I want to get. Positive 5c. So my answer is 2c plus 3 times c plus 1, but I've got to remember to put this negative sign in front of it because I factored out negative 1. Well, that's our second lesson on factoring quadratics. I hope you learned a lot. Now it's time to test your skills. Go to www.mastermath.info and you'll see worksheets and quizzes there that'll help make sure you understand this concept. We'll come back and see us again real soon.